Ask yourself, are we just trying to save a few dollars, or we are building a process that is truly efficient and cost effective? From my experience, many managers simply don't know the difference between cost cutting and lean efficiency. They believe they are saving money. But in most cases, it's short-term thinking. These choices harm production, people, and product quality. A manager might save $100 right now, but a few months later, those savings lead to $1,000 in hidden losses. This happens more often than you think. With every such decision, the company loses more money. Lean manufacturing is not about making one smart decision a month. It is about fixing dozens of small problems every day. This is how you build a strong and efficient system. It's about improving operation in smart ways, not blindly cutting what matters. Sadly, most decisions on the production are based on saving money right now, not building long-term efficiency. So, what does lean manufacturing involve in real life? Train your staff. If someone lacks knowledge, teach them. People must understand what they are doing, how to do it, why it matters, and what quality is expected. Improve worker efficiency. Everyone should have a clear KPI. Optimize your soldering and assembling processes. Look for smart ways to speed up production. Never sacrifice quality. Prevent assembly mistakes. Eliminate human mistakes wherever possible. Record and analyze all mistakes. Keep them organized and use that data. Cut wasted time. Even saving 10 seconds per task add up across big batches. Reduce material and supply usage, but don't go too far. Use your equipment more effectively. Prevent unnecessary stops. Avoid downtime. Keep people and machines busy in safe, balanced ways. Eliminate bottlenecks. Don't let one slow step block the entire process. Choose the right equipment. Use it for the job it was meant for. When you improve everything a little, the results add up, quality gets better, speeds improved, and you use fewer resources overall. Share your stories in the comments. I'm sure many of you have seen similar things. Right now, I want to share with you my examples. Example with Stencil Inspection. Some PCB projects repeat every few months. I always check the stencils before starting such jobs. Yes, stencils wear out. What do I check? Dents, scratches, damaged apertures, and thickness. If the last batch had paste-related defects, I inspect every more carefully. Sometimes the stencil must be replaced. This may sound unnecessary, but it prevents major problems. If there is too much soldering paste, you get current shorts. Too little, weak soldered joints. Components might float or short. That's not the machine fault. It's because the uneven or excess paste. I log these cases. Every project has a defect log. That helps spot the issue early next time. Rework is slow. If there are 10,000 bad joints, fixing them could take a weeks. Even if you stop the line in time, that still costs money. If your managers say that ordering a new stencil is a waste, they are wrong. That's not lean, that's short-sighted. Next example, repair PCBs without a microscope. Imagine contract PCB assembly manufacturer. New project arrive every day. Some are new, some a repeat job, sometimes they are come back to back. Two PCB boards have issues. The board are moved to repair area. You walk in and see coworker trying to fix equipment components without a microscope. That doesn't work. Microscopes are most important tool in PCB repair. If a coworker says that he sees everything well, then this is definitely not true. They are guessing, and that leads to bad results. The fix is simple: buy a microscope. Even a microscope for a few $100s is better and will improve quality and speed. But only the microscope are not enough. The coworkers need skills. They must know what they are doing. If not, train them. Take IPC repair courses. Coworkers also need hands-on experience. Without tools or knowledge, you can't expect good results. Some managers think they are saving money by skipping microscope or the tools and training, but they will lose several times more money when fixing bad PCBs. If rework is fast, people can move on. If not, defective PCB boards pile up. One person can't keep up. Stress builds, customers complain, managers panic. All of this happens because of one bad decision, ignoring the basics. What microscope or tool do you use? Write in the comments. Next example, ESD protection. Many electronic productions have no ESD protection at all. Maybe grounding only the big machines, but nothing else. No ESD mats, no wrist straps, no ESD floor. People wear sweaters in winter. Windows are open, air is dry, and these people are assembling PCBs. Maybe yours. You can ask them, what if tomorrow you get the PCB boards with ESD sensitive components? That could happen any day. Without proper ESD protection, electronic components can be damaged by a simple touch. I have seen it. Sparks fly. Meanwhile, ICs are getting damaged silently. Then what? For example, you have 100 defective printed circuit boards. Who is to blame? I have seen the excuses: bad design, faulty parts, defective batch from China. But the truth is, the company did not invest in ESD protection. That's not about lean, that's bad management. Real case: 1000 PCBs. Processors were ESD sensitive. After manual handling, more than 800 of PCBs were damaged. Why? Static discharge from the assemblers while installing the board in the boxes. And yes, all of this can be avoided, but many productions keep skipping ESD protections to save money, or from a lack of understanding of the processes. PCBs suffer. Next example: manual PCB cleaning. This is a big problem in many repair shops and assembling productions. Many still clean with isopropyl alcohol or random chemicals. For cleaning soldering flux with isopropyl alcohol doesn't work every time like you want. A white residue may occur. Assemblers start scraping the white residues with tweezers. The mask is ruined. Why? To save money. No cleaning machines, no proper cleaning solvents, just rough work. It ruined the PCB board. It's ineffective. It costs more than buying the right PCB cleaning equipment and special liquids. Next example: ESD brushes. Two brushes. One is ESD PCB cleaning brush. The other is a paint brush. You see assembler scrubbing flux with old paint brush. The brush was almost bald, it did not wash off the flux. You tell the manager, replace it. Assemblers need the right tool. One ESD brush costs $16–80, but it lasts much longer. The company will save the assembler's time, the manager time, improve the quality of the PCB boards and the speed of the process. The right tool will lead to lean results. Last example: ESD gloves. Assembly receives ESD gloves for soldering, then uses the ESD gloves to lubricate some machines. The next day ESD gloves are unsuitable for soldering. However, there are gloves for oil and grease in the warehouse, but no one told him. This leads to unnecessary waste and overuse of materials. No one explained anything. Now, imagine that 40 employees do this every week. Gloves, soldering tapes, forgotten lighting, dozens of such items, and in indifference. This is important. Like and comment if you think this way of thinking is correct in production. The difference between lean and greedy production is huge. Lean is a structure, analysis, training people, the right equipment, culture, the right investments. Greed is when you skimp on important things and pretend that it is efficiency. Sometimes no one in the productions knows what to do. It happens, but when it does, the damage can be huge. What similar problems have you seen? What has helped you improve your lean process? Subscribe to my YouTube channel, like and comment what you think. In description on this video you can find links to my Instagram, my Telegram group, to my website with soldering fluxes and electronic consultings, also to my Patreon. Thank you for watching, bye bye.